Is being recorded.
October Power Systems Virtual User Group. So I'm going to go ahead and share my screen here. Just want to kick this off. Welcome everybody. Say happy Halloween. I do have a couple of things here before we get started today. First of all, I have everybody online, all of your attention, so I get to do a little bragging. If you follow me, and the VUG sessions, you know that my daughter got married in June. It's been a busy house in the Armstrongs. My son got married this month in October in Bend, Oregon, so I get to share wedding photos with you all. You never know it. He's a PhD chemist, and his beautiful bride is a master's from MIT chemist, so a couple of smarties. It's really interesting to hear them talk and all their chemistry stuff. So a little family photo down here on the right. So the guy in the middle there is the middle son. He's still single. I have 3 kids, so he's the one that's not married yet. He actually performed the ceremony. It was very interesting. So anyway, a little bragging, enough of my bragging now. I have one other thing I want to try and do here. If I can, I'll have to bring up a poll. Let's see. I was going to try and do a poll today. I might have to wait that for a minute. Let's see here. If I'll open the poll questions. Okay. And I have some poll questions here I wanted to put up. So can you see the poll questions, Ron?
No.
All right. Let me try sharing again. And now can you see the poll questions?
It's starting. I see your kids. They're good.
Yeah. Still can't see the poll. Yeah. Oh, here we go. Polling. Open the poll. All right.
Oh, there it is. There on the chat side, yeah.
Hey, all right, guys. So if everybody would take a few seconds here and answer the polls. So they changed the WebEx a little bit on me. When you're registered, you can no longer, I can't ask the questions right now of, are you an IBM or are you a customer, a business partner, what's your title, who do you work for, stuff like that. So I'm going to put up the poll here and just see if I can get a little bit of information from you. Hopefully I can get those questions back in the future. I'm working with a WebEx team at IBM to see how I can do that. So anyway, that's ongoing. So I appreciate it if you could just take a few seconds and give me an idea of who's out there. All right? So while you're all doing that, I'll just start a little bit with the introduction. First of all, the presentation materials for this are up on the wiki, and I am recording this session. So you're all being recorded. Just a little bit about today. Normally I have IBMers, give most of the talks on this. Today's a little bit different. Every now and then I've gotten somebody that's not an IBMer, and today is one of those times. So Ron Gordon is going to be talking with us. Ron did work for IBM. He says for over 40 years, and if I do the math, that makes him getting up there in age a little bit. But he's been working 15 years in power systems and with Linux extensively, with Linux on power since 1990. So Ron isn't an IBMer right now. He works for Mainline Information Systems. Mainline is a IBM business partner. Ron supports over 300 power customers with Mainline. One of the special things about Ron is he is an IBM champion, one of the few people outside of IBM that is recognized as somebody that does extra special work above and beyond that promotes IBM products, and in this case, IBM Power Systems. So Ron is truly an expert in his field and does a lot. And with that, just really happy to have Ron as a first-time speaker here for the Power Systems Virtual User Group. So this is going to be great. So with that, Ron, I'm going to stop sharing, and I'm going to make you the presenter. And you know what? I'm just going to let you take over then as soon as I get this. All right, there you go, Ron. You should be able to share now.
All right, but I gotta find where I went. There it is. All right. Hey, Joe, you should be proud of your kids. You can brag all you want. I think they're doing great. I
They
think
are
they're
great
doing
kids.
great.
Thanks, Ron.
Yeah, yeah, absolutely. Two PhDs. So you'll never be involved in those conversations.
That all goes over my head.
Hey, Ron Gordon here, and what I Joe and I talked about what we might talk about on this, and we came up with a couple of subjects. This one is for the next period of time. Going to talk about Linux development, meaning how is Linux developed, and how is it differentiated on power? Jeff Shield, who's was the chief architect for Power Linux up in Rochester, and I used to get into big debates. And Jeff's opinion was Linux is Linux is Linux, and my opinion was no, it's not. They are different, and that's where I'm not gonna take a side on that right now because I'm not gonna promote that I'm right and Jeff's wrong or vice versa. There's my happy Halloween penguin to y'all.
I don't think you're sharing right now, Ron.
Well, what do I have to do?
Well, you have to go up to that share and say, share my
Oh,
screen.
oh, well, wait a minute.
No happy penguins yet.
Okay, so how about now?
Oh, we're getting there. We're getting there. Well,
Yeah.
there we go. Now I see the snow. There's the happy penguin. Okay.
All right. What do you see now?
Light bulb.
I gotta see what the delay is. All right, there's my email. So what? All right, so there's the penguin back. So this session is going to be a little bit different than like when Nigel does them, or Gareth, or Jackie Lynch, or Glenn Corneau, where they actually teach you something that you can use. And you probably take notes and learn how to use certain new commands on the HMC, or Nigel's opinions of um, shared storage pools, which is always interesting, etc. This session is more like a history lesson, right? And that's the first topic. And the reason I want to go over this before I get into development, which is like, so what? But it's also how power Linux for power, I don't know how to say that, is really different than some of the other Linuxes. And obviously today, Linux is becoming more important on power systems. Certain facilities like the virtual HMC, like Power VC, et cetera, are all going to require Linux as IBM continues to promote correctly, not incorrectly, as IBM continues to promote artificial intelligence. This is all going to be done on Linux. And the power systems have a great advantage over x86 systems from a performance standpoint. And then you've got such things as SAP HANA, which is going to require Linux. And there's an awful lot of SAP users out there having to move to HANA eventually. So I like the opinion that Linux on Power is different than Linux on x86, which is the other prominent platform. So that's basically what I want to cover. You're more than welcome to ask questions via the chat, and I'll stop every now and then. But this, you don't have to take notes. You've got the deck, and there's not really much you can do with this, except when you get into a discussion with a customer, or a customer has a discussion with upper management or decision makers about, well, should I run this application on Power or should I run on x86? Or, hey, I've already got Linux on x86 and it's perfectly fine. Why should I even look at Power on Linux on Power? Well, so why is it important today? Put a couple notes in here. This is an old chart, but I made them some of the things in blue. When Linux came out, it really wasn't stable. It wasn't really functional. It had very limited capabilities, but that was in 1991. And it's rapidly grown. And some people today and historically said, wait a minute, I can't run mission critical workloads on Linux. And I think that is totally debunked now, because people are running mission critical apps. If we don't think SAP HANA is mission critical, then we are confused. And they are running on Linux. But the other thing down here, open source is bringing new capabilities. And in my opinion, almost all open source is really Linux oriented. So new capabilities in databases, the Mongos, Cassandras, Kineticas, and so on. That's where the development is by communities or ISVs. I think you can recognize that almost all ISVs are creating Linux distributions, be they Epic, Cerner, SAP, etc. So there's this statement about the ubiquitous of Linux and open source. And Linux enables you to choose the platform that makes most sense. Because in theory, and I will support and debunk that theory simultaneously, you can run Linux on any platform, which potentially implies you can run any application on any platform. I'll talk about that. But I really think that that's an important point. If you have a mission critical application that you want to run, wouldn't it make sense to run it on a mission critical platform server? So if I want to run SAP HANA or artificial intelligence, which is critical to my business, wouldn't I want a high performing hardware platform to run that on that doesn't fail, that has certain characteristics that make it enterprise ready, such as virtualization, enterprise pools, all these other things? Well, that can be done with Linux on Power, but it cannot necessarily be done with Linux on x86 or other platforms. I'll try and mention ARM later. So that's why I think it's critical that we, the people on this phone call or webcast, understand how Linux is developed and how Power is differentiated. That's not what you dwell on, but that's what I want you to try and understand. So what's Linux? Well, Linux is an operating system. It was written in '91 by Linus Torvalds. And just a little story on that about Linus. Linus now works for the Linux Foundation. When he moved to the United States, the Linux Foundation had a different name. It morphed into the Linux Foundation. It's located out in California. And Linus owns the copyright to Linux, which is an interesting statement because nothing can be done to the kernel. He basically owns the kernel without Linus approving it. Otherwise, somebody's in copyright violation. So that's just a piece of information that's not of much value. It has a lot of functionality now, and it is now stable. It's been stable for many years, probably starting with the 3 or 4 kernel, and it has added lots and lots of security features. So we're in good shape. Whoops. You can run on any platform. Maybe not. We'll talk about that. And for Power, and for other ones, there are 2 things. The Red Hat code is generally cannot be charged for because it's managed by something called the GPL, the General Public License, which says the code base has to be free. And if anybody changes any of it, any of the changes to that GPL code base, subscription licensed, has to be also made available for no charge. So the question that many people have is, well, wait a minute, how does Red Hat, SUSE, and these other people make any money? Well, they offer a subscription, which means you can have the code, but we're going to let you subscribe to it for a year or 2 or 3 or 5, and you will be able to get all your updates. So it's an update subscription, kind of like ordering a magazine. If you buy 1 copy or you take it from the barbershop, you got 1. But if you want it to come every month and be up to date, you get a subscription. But the other thing they offer is support because the Linux product is community developed. So who do you call if you have an error? Well, you can post questions to certain websites, or you can get support from Red Hat, SUSE, indirectly, Canonical, but you can't get it directly from Debian or CentOS because those are community developed, and therefore the interface to that development community is via the website. And by the way, if you post a question to Debian or some of these community websites, you will be inundated with responses because the developing community of these distributions are very proud of their distribution, and they love trying to help you. But if you look at the commercial world, as opposed to universities, research organizations, etc., if you take a look at SUSE, Red Hat, and Ubuntu, that probably represents over 95% of the Linux commercial market. I note commercial market. I didn't say HPC in some of these internal ones because that has an effect of distributions that support the ARM architecture, which is changing quickly. Two websites that are normally not visited, but if you want to find out some information about the development and what's changing in the kernel, I'll define kernel in a moment. There's a website, kernel.org, where the latest kernels are all freely available, historically available, and the future kernels are available for download. No charge. Download it. The kernel is normally compiled via the GNU compiler, the GNU C compiler. GNU standing for GNU is not Unix, whatever they call that thing, but that's, again, trivial, useless information. But you can download the kernel, and you can download the GNU C compiler, and you can compile it. And when you do that, you'll have something that is absolutely useless because you can't do anything with it. But I'll talk about that also. Then there's the Linux Foundation, which is where Linus works, and he manages projects where the kernel is being enhanced. The Linux Foundation obviously also has several lawyers working there. So if we look at Power, Power can run Red Hat, SUSE, Ubuntu, CentOS, Debian, and there's a couple forewarners of Red Hat called Fedora and of SUSE called OpenSUSE that run on Power. But if you look at that, we individually might think, well, there's only 5 distributions. Well, we'll talk about that in a second, but if we go back into history, there was only one. So in 1971, Unix was developed in Bell Labs as a project for computing, for high-performance computing. And then now this is very brief. In 1983, the GNU is not Unix, Foundation was created as GNU open source project, and it took the Unix from Bell Labs and continued to expand it. And their objective was to create free software, and Unix was the base of that coming out of Bell Labs. In 1985, the general public license was created to ensure that GNU projects would retain its free software basis. In 91, there was this guy, Linus Torvalds, at the University of Helsinki, who took the GNU project as a college project and wanted to make a ubiquitous kernel that could run on any platform. And internally, his project was named, I don't know the pronunciation, I'll just say Freax, which stood for, by Linus, Free Freaking Unix. Now, he had an assistant that helped him do the compiles and the runs and tests and so on. And that assistant, whose name is probably lost in ubiquity, liked that name, Freax. So without Linus's permission, he renamed it Linux, Linus's Unix. That's where that name came from. And another piece of trivial, which is sometimes lost in perpetuity, is at some point in time, I don't know the date, that people asked Linus in these meetings, hey, everything has a mascot, right? Well, not everything, you know, the San Diego chicken, Colonel Sanders chicken, et cetera. Yeah, they have mascots. I asked Linus, well, what would you like your mascot to be? And he said, you know, I like penguins. So that's how the penguin got to be the Linux mascot. Um, and then they dress it up like Halloween characters, etc. Now, in 1995, Linux was adopted by two communities that really accelerated it. The supercomputing community as a whole and NASA to accelerate it and use it because they always had to modify it. And if they were using commercial available operating systems, they could not accommodate what was needed for their work. So now the Linux kernel exists, but in distributions, the Linux kernel is augmented by GNU components, that community still exists, by non-GNU components, the open source community. Packaging options, meaning what am I going to put with the kernel? Should I put a user interface? The kernel doesn't have one. Should I put a web server? The kernel doesn't have one. Should I put a file system? Should I put various aspects that I need to make this thing run? That's called packaging. And then options by the distributor. Those are chosen by the distributor. And I'll talk about the options also in a minute, like the install option, like the support and maintenance options. And those are the things, that last column that says now the kernel exists, and that's semi-fixed, but the GNU components, the non-components, the packaging, and the options are chosen differently by different distributors. So Red Hat is different than SUSE, is different than Ubuntu, is different than Debian, is different than CentOS, kind of. This is an interesting chart. If it comes up, I'm assuming it's up, Joe. Because what it does, it kind of puts that in perspective that says back in the early 70s, Bell Labs came out with the Unix kernel, the Unix operating system. So that then, if I go down the stack, and around the mid 80s, or beginning of the 80s, commercial Linux has started to be created from that Bell Labs environment. And you can see that HPUX came out before AIX, and then Solaris came out, and then UnixWare and IRIX. Now we can look at that today, and you see a lot of these lines have terminated, like IRIX, UnixWare, and although HPUX is still out there and Solaris is still out there, those two organizations have basically said, we're not really serious about Solaris or HPUX anymore, whereas AIX obviously is still a very serious operating system as continuing development. Just for a reference point, the AIX development team is probably composed of about 300 developers and testers. So that's the AIX development environment right now. And you know, you can talk with Sheffield or Carl Burnett or Petra about what's coming. In fact, they just announced a 7.2 release that'll be out in December. So now if you take that Unix line and you go up, BSD came out. And then SunOS came off of that. This is all freeware. FreeBSD came out. But then you see this GNU project, and that's the one I mentioned, came out in mid-1980s. And GNU then was taken over as a project by Linus, and the green line continues as the kernel development. And this says 4.11, which is a little old because it's really at the 5.3 kernel level right now. So that's how this Unix-oriented operating systems came around. And you can also see Mac OS up there and how that came out. And that's very valid. I've been told don't install the latest Mac OS release. Give it a little while, and then you can go to it. So there's a flowchart that's absolutely useless. So the kernel evolution. So, you know, Linus started that thing, and it went on for a while, and it had no designation. He finally came out with a designation, kernel release 1.0. And that was the formalization of the distributions that people could use. And it was based on the Intel 386 architecture instruction set. So that went along for a little while. You know, I've obviously left out a lot of stuff on this. But in 1995, the 1.2 kernel came out, and it added Spark, Alpha, and MIPS architecture to the kernel. So you could now run Linux on a Spark-based computer, an Alpha-based computer, or a MIPS-based computer. The 2.2 the 2.2 evolution came out in 99, where the Motorola 68,000 and the PowerPC architectures were added. Now, it's interesting, right around that same time, another operating system distribution came out called Yellow Dog. And Yellow Dog was the first distribution to support Power. Have a distribution that was compiled for Power that you could download and run. 2001, PA RISC, but they also added some other things, which was significant if you think about it. It was 2001, they finally added USB support, Bluetooth, a file system, LVM, RAID, and PCI devices. Not until 2001, although that's now almost 20 years ago. 2003, they made a big step. They added security enhanced Linux, which was written by Alan Robinson in the, I think he worked for IBM at that time. They had a journal file system. They upgraded the ext3 to ext4, and not until 2003 did they have 64-bit computing. Of late, the 3.0 kernel added ARM, and the current kernel, 5, added patches to Spectrum Meltdown. Now, obviously, there's other things built around that kernel, and if you go out to the kernel.org site, you can see every line of code that's been added and a high-level view of what is being added. I've put these elements in because they tend to be oriented with servers and running mission-critical application code, as opposed to things that are added for cell phones and gaming devices, etc., or automobiles. I didn't put those in that list, but that is also some of the development. If you take a look at it, there's approximately 1,700 full-time developers. But these do not necessarily, they don't work for the Linux Foundation. The Linux Foundation manages the distribution of the kernel, the acceptance of the projects that are extending it. So these developers do work in very well-known companies, and they're listed up there. Intel, well, we can understand that. As Intel changes their architectures, they have to be reflected in the operating system. Red Hat, it would be good if they advance the operating system based upon, whoops, I went the wrong way, based upon what they're hearing. Linaro makes adapters. So if you consider every time an adapter comes out, it needs device drivers, etc. So that's a natural to add to the kernel. IBM has about 600 developers and testers in the Linux Technology Center and testing organizations that contribute to the kernel to support Z, Power, IBM storage, etc. Samsung, big. Devices, memory. SUSE is an organization that's obvious. Google, now Google runs all their systems not all, on a Linux derivative. So as they see advancements needed for their massive clusters, they can contribute. AMD is adding, and Renesas and Mellanox, again, are a device. These are the primary developers. The Linux kernel, as of 4.13, was 25 million lines of code. So you can see how it has grown up through the 5.4 kernel. It's actually, the 5.4 is a future kernel. It's not out. The 5.37 is the current stable release, which is in node distribution. So that's what's going on. It's just to make you feel good. So Linux distributions on power. Now, what does that mean? Well, the primary distributors, I can use that word, that commercial customers might be interested in, is SUSE, Red Hat, and Ubuntu. Now, these have been developed by SUSE, Red Hat, and Ubuntu, the distribution, but they are tested by IBM on the IBM Power servers. If the test team and development team in IBM, in the Linux Technology Center, sees an issue, they submit that to SUSE, Red Hat, and Ubuntu before the distribution based upon the current kernel is released. So it's probably not up to SUSE to get every one of the power servers and test them all, because they have a plethora of them right now, including Power 8. You have to do the back level, and Red Hat's not going to do it, even though they're part of IBM now. And Ubuntu cannot afford to buy all the power servers. They have a few, but not all of them. So IBM tests them. Now, OpenSUSE is the beta version of the next release of SUSE. Fedora is the beta version of the next release of Red Hat. CentOS, notice the arrow goes the other way. CentOS is a community developed organization, and they take the Red Hat distribution source code and change it as they wish and make it available on the CentOS site as a download. Ubuntu comes from Debian, which is an open source community development. I'll show you where that comes from in a second. Ubuntu is interesting because Mark Shuttleworth was very wealthy, probably still is, and he wanted to do something for the world. Initial focus was on Africa. So the word Ubuntu comes from the Zulu language, and it has a long phraseology, which means indirectly, persons are people basically by working with other people. So the idea of Ubuntu is community or humanity through others. I mean, that was what Shuttleworth's philosophy was. He wanted to enhance the community. So he created computers and put Ubuntu on them because he could get it for free, and ship those to countries for no charge. So that was an altruistic initial development. And it still is, because Ubuntu is no charge, download it, etc., unless you order it from IBM, because then it's $738. So there's our distributions. But the thing is, there's 7 on that list. Are there only 7 distributions? And the answer is absolutely not. There's over, I'll say, 800 distributions that you can choose today. Any one of your customers, or you as a customer, can choose a Linux distribution compiled for a platform that has certain characteristics. And if, on the other hand, if you wish to be a Linux distributor, you could download the kernel, go get some stuff from GNU, go get some open source stuff, put it all together in your garage, and say, I've got the Joe Armstrong distribution. Or his kids can have the chemistry distribution. It'd be great. I don't know if anybody use it, but I don't know how they support it. So what's happened? Well, uh, over there on that semi-fuzzy picture, those are the 800 distributions and how they map. But it turns out there's really only three roots of all evil. That was an old economics teacher's phrase. The root of all evil is economics. And really, Debian, which came out in 1993, spawned Ubuntu. So the Ubuntu development team, a la Shuttleworth, took the Debian distribution in 2004 and made that advancement. Slackware. Now remember, I said that the original distributions in the early phrase were picked up by supercomputing. So Slack, being one of those, created their Linux distribution. And in 1994, SUSE picked up the Slack distribution and started making their SUSE ones. Now, SUSE is German. I used to be able to speak German, but not anymore. But it's the last word is Enwatan, which means lab, and I think system is the first one, and I forget what the U and the S are in the middle. So that's a German word for basically the German lab. Red Hat picked it up in 94, which begat Yellow Dog. So they took the Red Hat distribution, which was not on x86, excuse me, was not on Power, and they created a PowerPC distribution in 1999. That was the first one for Power. And then that begat CentOS in 2014. So there's your distributions and where they came from. Now, I just put these in Red Hat family tree. Red Hat's the dot all the way on the left, and then all the things that spawn from it. So even if you blow this up, you may not be able to read it, but that's what this is. There's lots of them. And if you take a look at Slackware, they came out, and if you look at the very bottom of that, you'll see the word SUSE, and the word SUSE has these derivatives that came off of SUSE. And that's the high performance computing one. It's also interesting to note in talking to a name familiar to you, Jay Krumke, that SUSE is very interested in high performance computing, ARM computing, etc. And their genesis was in high performance computing. So it's a natural tie-in from the lab perspective and potentially the usage. And then Debian came out and spawned 177 derivatives, most of these being very open source. If I go back to the Red Hat one, I'm not going to, such things as language deviations were created. I shouldn't say deviations, extensions, like for Japanese, for Chinese, and so on. There was a distribution called Red Flag, probably still out there for Chinese languages. And what they do is they take Red Hat open source, take it, modify it, and package it and distribute it. Ubuntu, 78 derivatives. That's enough of that. So that's where this stuff is coming from. So in the middle here, we shouldn't have the idea that, well, I'm sure we don't, that Linux kernel is only for servers, because the Linux kernel, the red block there in the middle, contains many things: process schedulers, security modules, filters, et cetera, file systems, drivers, device drivers, et cetera. And that may be good for certain things, but some of those things probably won't work in an embedded computer, like level 3 switches on networks, like the very bottom block. On-prem equipment, measuring equipment that's out in the field, et cetera, sensors, et cetera. So that base kernel is taken and modified by somebody like Linero or an ASICs manufacturer or something. They take that same kernel for desktop computers, for mobile computers, for smart books, tablets, phones, etc., and they modify it. for wristwatches, etc. And then in the top block is where we primarily, I say that proprietary standpoint, that we're probably all more involved with computer clusters, mainframes, servers, etc. That is then taken by a certain hardware community, and they add human interfaces and changes so that that kernel can be used more efficiently in that environment. So I'll talk about that in a second. And then over on the other side is the GNU added pool of freeware that then extends the Linux kernel so that it can actually do something. I think we all recognize if you have an operating system, that's not very exciting. You need an application to run on it. That's exciting. So how's the kernel looking? The kernel looks like this. The kernel starts at the red up. The kernel basically is the application interface to the hardware. Now, in many systems, between the platform-specific code and the Linux kernel is such stuff as phype, the rings in x86, Opal, and so on. So the Linux kernel has certain interface calls that go to a hypervisor that then call the hardware. So right away we can see that the Linux kernel, in order to get to power hardware, needs to interface to phype or Opal. Well, that's different than x86. Oh, but Spark systems don't have that. They have a different hardware interface layer. Oh, so that's different. More about that in a second. So here's this big Linux kernel, 27 million lines of code, but then platform-specific code so that it can talk to libraries, device drivers, etc. is needed. And then on top of that, you have Linux applications. Now, Linux applications are interesting because the theory is that the Linux applications will run on any Linux kernel or Linux distribution. I'll use the word kernel more accurately there. And I'll take a look at that too. So that's basically the way the kernel looks. But here's the way it looks more in depth. If you take a look at the Linux kernel down at the bottom, you'll see at the very bottom is the hardware. So the Linux kernel talks to the hardware, the processors, the memory and the memory subsystems, the VMMs, the data storage devices, etc., such as I/O interrupts, error recovery routines, and I think we recognize that these are different between Power, Z, x86, ARM, etc. So for example, the way Power hardware manages main memory through the tables and the TLB processing is all done in the hypervisor. Whereas in x86 running Windows, it's not done there. It's done in the operating system. So the kernel better recognize these differences. If you take a look at the processor, the Linux kernel has to recognize that the power processor can support SMT8. Whereas if they're doing the dispatching on x86, they can only do SMT2. Kernel has to know that, just like AIX is the one that spawns the threads and interfaces to the hardware. So those are differences. So as you move up, you have to interface to these. The other one is storage. In power systems, there's a lot of reliability characteristics implemented, such as device retry. This is based on the characteristic of the device driver as implemented through or adapters, which can provide retry bit codes to tell the operating system don't crash yet. Retry that, because most of the device drivers can sense a flag of Fox that says, try it again, operating system, before I send you a fatal error. And sometimes there is a fatal error. Then he will crash it. Processing, the schedulers, process scheduling. Talk about that in a minute. IP subsystems, memory management, those are the things I talked about. But then the C libraries have to be written to the specific instruction set architecture. And then on top of that, the daemons are also associated with hardware as to which ones are running. Same thing with the user interface and so on. So this is a deeper view of the construction of the kernel. Now, if we take a look at how many lines of code that is, now this is somewhat antiquated. This is probably from a 3.0 kernel. Here's the number of lines of code that are associated with those various components. So it's a very scalar environment. Now, what happens here is that, I'll go back to history, as Linus was developing the kernel, for example, he did not have a very good memory management environment. It was kind of basic. So what he did to the open source community that was helping him advance it, he posted, hey, is anybody who interested in doing a project on improving the memory management? Is anybody in a mode to help LVMs? Is anybody in a mode to help me with IPsec? And as they did, he spawned those work groups, took the input, integrated it back into the kernel, and put it out. So that's how the Linux Foundation continues to manage and advance the kernel in servers, and obviously there's other changes being made for gaming devices, internal embedded compilers or internal sensors, etc. But notice up at the top of this, there's a section called ARC. That's the one I want to focus on for a minute, even though I'll branch into some of the other ones. So from the 2.6 kernel, and it's extended since then, but how do I make Linux recognize the different architectures? Not through just the instruction set architecture that I'm compiled to, but how do I make it recognize that power, virtual memory management, is done differently, and that I have SMT8, and that I have error recovery? So it turns out that these characteristics of power are in these architecturally unique sections of the kernel. And as you can guess, we'll do if-defs to compile them in or to exclude them if I'm compiling for x86. Now, who do you think writes those sections? Well, I bet it's the power team, because Red Hat doesn't know how our hardware works. And how do they know how Power 9 is going to differ from Power 8 when the Red Hat team or the SUSE team or the Linux kernel team does not have a forewarning of the changes that are being made? Well, the IBM Power team is doing that. And by the way, most of those changes also end up in AIX and IBM I. So the hardware architecture team promotes changes to AIX. And since AIX is similar to Unix, to Linux, these somehow get propagated into the Linux kernel. Same time, a system or Intel is working on the x86 next step, whatever that is. SPARC was doing SPARC changes. 390 is our current Z. That's how these architecturally unique sections are in there. If you take a look at power, power has many characteristics that have to be reflected or are reflected in the operating system. Some of the characteristics of Power VM have to be built into the kernel. Java optimization. If I optimize Java for one particular environment or one particular JVM, I may not be optimized to the other, because right now the IBM JVM differs significantly from the Sun, Polaris JVM, Larry's JVM, than the x86 JVM. Capacity update on demand. This was something that was added because a long time ago, I don't know when, the kernel would run, and it would just run. So the question is, I want to change your resources. I want to add memory, or I want to add or subtract processors, cores. Well, you can't do that on the fly. So IBM had added to the Linux kernel something called kernel idle. And it was a command to the kernel that said, hey, stop running, because I want to change something, like adding or subtracting resources or adapters. We had hot plug. The other operating environments did not. So we became unique because we had added to the kernel idle, which then on the restart of the kernel, you could modify the resources. The affinity relationships that are in the hardware have to be recognized so that things like ASO, DSO can be maintained in the 930 microcode forward. Virtual memory management, page size is different. It used to be that the Linux kernel only worked on 4K pages. Now they don't. They default based upon different operating systems, but the large page support is standard in power. So it's the 64K page, 64 meg, whatever it is. We have SMT 8. And we've got the power instruction set architecture, including power 9 changes to transactional memory, atomics, etc. Those have to be in the kernel, just like those have to be in AIX, or you don't get the capability of the hardware being exploited by the operating system. So the IBM development team, hardware, software, take these changes and put them into that architectural section. Now, that's the kernel. Again, the kernel can't do anything. I mean, what am I going to do with transactional memory if I don't have a database? So that's kind of like, wow, that's neat. What's your point? What am I going to do with virtualization if I don't have any partitions running applications? So what happens is the Linux distributors add packages to their distribution. So that's why when you get SUSE, Red Hat, Ubuntu, you get Apache. Apache's not in Linux, it's a distribution. We'll get MariaDB. We'll get MySQL, not anymore. We'll get Samba. We'll get things out of this chart. They go out, the distributor goes out to the open source community and picks and chooses what they want. And they put it in the distribution. So now, this is the one chart that this is really all about, this session. I'm going to say that I am SUSE. And I am now going to create a distribution. I go out to the kernel.org site and choose a Linux kernel. It would be illogical to choose an old one because then I'm not getting the most advanced functions. So I picked the current Linux kernel. And the current Linux kernel that is called stable is the 537 kernel, running around 28 million lines of code. And SUSE downloads it. Now, in the middle of that code are all these architecturally unique sections. So what SUSE does, since x86 is probably the predominant architecture, they compile this for ARC. They take the compiler, the GNU compiler, and in the control statement say architecture equals x86 64, which tells the compiler to compile this code to the x86 instruction set and to include the Intel architecture unique section. Don't include the power, don't include the Z, don't include the Spark. because that's useless. They use the GCC compiler, and by the way, in the SUSE distributions, in all of them, they basically have available to you the full source code of the kernel and the GCC compiler version that they use. So you can modify it, which is not necessarily suggested. But they don't stop there, because then they go and get unique stuff that is not in the kernel, such as device drivers, administrative interface, installation processes, file systems, applications, and they package it with support around what they built. That gets put, it used to be put on a CD, not anymore. That gets put into a file on the SUSE site that can then be downloaded. That's how it's developed. Now, here comes Red Hat. Red Hat may choose the 5.37 kernel, but if it's a different point of time, let's say it's 6 months later, maybe the current kernel is the 5.42 kernel. Well, they download that kernel and they compile it for x86 just like SUSE did, but they also then do a second compilation and they compile it the same build tree. This is interesting. The same build tree, the same options, and they compile it for PPC-LE. Today, RHEL 8 forward and 7 forward will only be compiled for Little Indian. If they compiled it for PPC, like they did in RHEL 6, they would have a Big Indian distribution, and they would also create an LE. So there were two different distributions by SUSE and Red Hat, one for Big Indian, where they'd compile for Power PPC, and a second compilation for Power PPC LE, and they kept these separate. But the build tree was the same. What do I mean by the build tree? Inside of the Linux kernel, there are a bunch of variables and options, such as what is the scheduling algorithm for I/O? And there's 5 of them. There's one for sequential, there's one for priority, etc. I forget them all right now. So just like SUSE picked one, Red Hat has to pick one. There are things like, what is the garbage collection cycle? There are things like, what's the SMT setting? So there are over 200 of these. And the interesting thing is they, meaning Red Hat, SUSE, Ubuntu, they use the same build for x86 as they use for Power. And sometimes this is not optional, such as what is the I/O buffer size for networks? I think it starts at 4K. Well, in many large buffer requirements, you want that bigger. And if you don't, and that's called tuning, because of the usage, they optimize the build for x86, which may not be optimized for Power. And we used to do mainline, IBM used to do a lot of training on how to tune Power. And that's where they gave you recommendations for these 200 plus parameters and what you should change them to. And there's a command, system control, sysctl -ls, that will show you the settings of all of these settings. And you can then change them temporarily to see if it changes the performance, or permanently so that the performance is permanently increased. That'll set your SMT, your buffer sizes, your I/O schedulers, just all kinds of things that I don't understand anymore. But what are the odds? Oh, and then Red Hat goes out and picks some device drivers, an administrative interface, an install process, file systems, applications. Well, what are the odds that the Red Hat distribution chose the same devices and created the same build structure as SUSE, who potentially have optimized it for processor performance, since argumentatively they're oriented towards high performance computing, whereas Red Hat may be more oriented towards commercial workloads, TBCC type stuff, OLAP, and so on. If I was the developer and distributor of the kernel, I'd optimize it for where I want to be strong. But that's the distribution that they created from the kernel. And then Ubuntu comes along and does the same thing. They download it. Who knows what kernel they got? Who knows what build parameters they got? And who knows about the devices, etc. But there's 785 people doing this. So these are logically not the same. And the other thing that's not necessarily the same is what they've done. So if we look at Red Hat 7, for example, Red Hat publishes, and this is not a complete list, of what they've done to the x86 distribution as opposed to the Power version. Power being an architecture and x86 being an architecture. And they've enabled in the Power version for RHEL 7 CAPI enablement. Yes. Did x86 do it? No. Well, that makes sense since they don't have CAPI. But you can take a look at, they've done something, Performance Copilot, whatever that is, and cross-architecture Kerberos, whereas they didn't do that for Power. So there may be a difference between Red Hat 7.4 for x86 and Red Hat 7.4 for Power. I'll talk about that in a minute. So these things can be slightly different. And SUSE did the same thing with SLES. They publish a list. I took these off of the website, I think. Right? So you can see hot memory add was done for x86 back then, but it wasn't available in SLES 12 originally. The default page sizes for x86 was 4K. For Power was 64. So they can change the build stream for the distributions, and the build table is the same, and your sysctl is the way to look at it and change it. So there you go. That's consistency and inconsistency. At least they're based on the same kernel, but the kernel from Red Hat and the kernel to SUSE and the kernel to Ubuntu may be different, which is depicted in this chart. That orange, yellow line, depending on how you're looking at it, in the middle is the open source kernel development. And you can see x minus 1, x plus 1. Those are just points of time. I'm not putting any point of time on it. It used to be that the Linux Foundation said that they would only put out a major kernel release, kernel 4, kernel 5, kernel 3, every 4 or 5 years. Well, they broke that. They aren't doing that anymore. You never know when one's going to come out. But at some point in time, the kernel becomes stable. And those are the x minus 1, the x plus 1. Those are the dates. I just put them close to a year apart. Now, IBM inserts some code. P doesn't necessarily stand for Power because they also insert some Z code. Inserts some power into the Linux kernel, which then has the stable kernel becoming available at time x minus 1. Now, the next kernel may come out, X, a year later. IBM, before it comes out, inserted some new code. So you'll see IBM is inserting code into the kernel prior to the releases of the kernels or the dots. Now, here comes SUSE. They want to do some development. Well, they say, hey, look, we like some of the stuff that's in this kernel, so we're going to change, and we're going to go get the 4.11 kernel. So they grab it, and they put out SLES 12.2. Well, now Linux comes out with the next kernel, but SUSE is not refreshing it because they're still based upon that primary kernel, the 12 or the 3.4 kernel, whatever it is. Ubuntu comes along at a different time because they don't collaborate, right? They shouldn't. So they grab a kernel. It's a different kernel. What code's in it? Well, it's interesting. They've got more power code in it than SUSE does. And Red Hat comes along a little bit later and grabs the Red Hat kernel. The Z under rel Z does not necessarily represent Z. It's just an XYZ. So they grab the kernel. And look, they've got all this IBM code in it. Well, what happens to some of this code that came out after they grabbed the kernel? That's called backporting. So the distributors, SUSE, Ubuntu, can grab code from the kernel and add it to their kernel, compile it, and distribute it. But you can see the odds of these kernels being compatible, consistent, is very slim. And that's why I say opinion to run Schless and Red Hat should be chosen very wisely because they're not going to be the same. If you consider when Spectre Meltdown got added and what kernels are out there, you might want to backport the code, but I don't know which ones they backported it to. But if somebody grabs the 5 kernel now, they'll have Spectre Meltdown in it. But that doesn't mean if Red Hat does it, that SUSE put it in theirs yet because of this development process. So my contention, the kernels are different by different distributors, and the kernels are different from different architectures, Power, x86, Z, etc., because of the code that is added to support that unique architecture and the capabilities thereof. So I go back to an original chart. Choose the platform that is best for the application. And if I'm running SAP HANA and I'm a multi-billion-dollar company that's betting my business on those capabilities of SAP, I would want it on a mission-critical platform, which Power is, and I can differentiate Power from x86, hopefully easily. And then this is why the Linux kernel is supporting Power differently than it supports x86. I think that's clear, but maybe I'm not being clear. So that's Linux development, Linux history, why, in my opinion, Linux on Power is different than Linux on x86. Unfortunately, 86% of the Linux community is running on x86. So they're used to it. All of our customers and you customers have departments that are running Linux. Every one of them, I would suspect, right? I think I have a good rate of return on that, better than Vegas, on saying you all have one. But you may not have a Power one, Power Linux environment. Well, you can get the same distribution if you stay in the same distributor, because SUSE, Ubuntu, Red Hat create the x86 and the Power distribution simultaneous with the same build with the same kernel. So you will have consistency. But the Power one will have the capabilities of Power exploited. And I have an opinion that the Power hardware is more reliable, higher performance characteristics, more capabilities, higher capacity than x86, because that's what it's built for. But in this chart, I say, well, what about applications? That's where the Power opportunity diminishes, because if the Power application, if the application you want, Epic, is not compiled for the Power PC environment, you cannot choose Power. You have to run it on x86 Linux, which is where Epic can run today. IBM is attempting to work with the major ISVs. There's a lot of them. Make sure that their applications are also enabled on the Power platform. and obviously they're choosing the ones that are more mission critical oriented. Epic, Cerner, SAP, Oracle. Oracle doesn't want to put their database on Linux because they're going against the Oracle OEL license, Oracle Enterprise Linux, which is a Red Hat derivative one level back. So if I look at applications, there's a very interesting thing going on that probably is lost in meaning. First of all, there's kernel to user space, and that's that API that I had in a chart a long while back that said applications run on the user space to get to the kernel. And the API is where they come in, and then they interface to an application binary interface. Now, the ABI is published through something called the Linux Standards Base, way down there in the bottom on the left-hand side. The Linux Standards Base says you application providers, if you comply to the Linux Standards Base, then you can run on any kernel that's at that LSB level. If you deviate from it for performance reasons, for trying to get into things that do not have a kernel interface, you may or may not run. And the reason is on the left, and that's or right, because the kernel interfaces can change and stability is not guaranteed. This is the way the internals talk to the internals. That list of things which was in the kernel diagram with the names. Whereas if you stick to the API, stability is guaranteed, and the API is published through the LSB ABI. Now, there's nothing we can do about that. If I was an application provider, Epic, and I was going to want to run on Power and x86 and so on, I would make sure I am LSB compliant. Now, I promise you that if you talk to your Epic or Cerner or even SAP HANA salesman or technical guy, say, are you LSB compliant? Because I want to run SAP HANA on both Power and x86. They're going to look at you like, what? I'm not going there. But that's a construct of the Linux environment that guarantees the portability, which is one of the promises of Linux. You can take an application and run it on Linux, and Linux will interface to the hardware. Well, the applications have to be specific to talk to Linux through the LSB and standard APIs. And that's a compiler requirement. And we got Big Indian, Little Indian. Right now, all the Linux stuff is, most of the Linux applications are Little Indian, Linux 8, Red Hat 8 is Linux only, Schless 15 is Linux only, Ubuntu has always been Linux only. So if you're Little Indian, I'm not going to go into Indian, this has nothing to do with it. But here's a chart, Schless 15. Schless 15. There is no 13 nor 14 because those are superstitious in the Chinese environment, culture. So Schless 15 is at the 412 kernel, Schless 12 is at the 4.4 kernel, and Schless 11 is at the 3.0 kernel. So those have differences. The Red Hat 8 is at the 4.18 kernel. Well, that's kind of close to the Schless 15 kernel, 4.18 versus 4.12. Schless 7 is at the 3.10 kernel. And Schless 6 for a long, long time was at the 2.6 kernel. So stay away from that one. Ubuntu 4.18 is at the 4.18.4. Now, Ubuntu naming is 18, that's 2018, 04 is April. The 16.04 kernel is 2016, came out in April. And there's sometimes a 1610 or an 1810. I'd have to look up which ones there are. But the Ubuntu is on the 4.4 kernel. Ubuntu keeps fairly up to date on the latest kernels. But this gets back to my development statement to you of obviously these have different capabilities. Whether or not the applications need to exploit those is a different question. And none of these, theoretically, are at the 5 kernel, which has the embedded Spectre meltdown. But it can be, and I think it was backported by all of these people. So don't get scared that you have to go to 5. There is no one in this community that is shipping the 5 kernel. Just a couple of charts on pricing, because many times there's a complexity in choosing distributions. For example, Red Hat has a distribution. By the way, all of the distributions I'm going to discuss right now are the same. There is no difference. The difference between the Red Hat distributions is purely in terms and conditions, licensing, and price. There is no difference in the distribution. Same build, same kernel, same updates, same support, everything is the same. But Red Hat has a distribution at a lower price if you wish to run it on the Linux-only servers. Now, the Linux-only servers come only up to 2 sockets. These are the Ls, the LCs, etc., and AC. So, but they did a change recently where if you run it on an LC server, you're only allowed 2 virtual nodes, which is a virtual guest. So you can run, just picking the top line so you can read this. On an LC, if you only want to run 2 sockets or 2 servers, 2 guests, it's $400. If you want to run unlimited guests, it's $1,600. These guests are logically on the LC only rev, because the LC runs Opal, which will not support PowerVM. So by definition, these are rev distributions, and possibly the first one may be used on something like an AC 922, where you logically may not be virtualizing that for performance reasons. Or if you're doing high performance computing, you probably would want the first column because it costs less and you're not going to virtualize it. Now, if you're going to virtualize it, you should get the second column because rev comes with it, even though rev is in every distribution because they are not differentiated. That's a different point. So there's Linux-only servers. Then for non-Linux servers, like the S scale-out models, the enterprise models, they license it by, for every 4 cores and 4 virtual guests, it costs this amount. Now, this is a price reduction, significant. This number used to be $795 for Red Hat for 4 cores and 4 VMs, right? Because you cannot run KVM on an enterprise server or an S box because they don't have Opal, they only have phype. And KVM can only interface to Opal, and PowerVM can only interface to phype. So by definition, this chart is PowerVM. So you'll see that the second column that says RHEL with smart virtualization, which is KVM, is an NA because it doesn't run. So for every 4 cores or 4 virtual guests, $135, and then pick your support. RHEL 7 right now, interesting, has a different price than RHEL 8, and I don't know why, except for this one. By the way, I'm not going to get into that. Now, SUSE, kind of straightforward. You want to run 1 to 2 sockets with 1 to 2 virtual guests, there's a price. You want to run unlimited guests, there's your price. And it doesn't matter if you want to run it on a LC, an AC, an S, or an enterprise. That's it. I think Red Hat is trying to get to this model to eliminate confusions. On Red Hat, on SUSE, KVM is included in the distribution but IBM says that that is not a supported environment. They have not tested it, and I'm just going to leave it at that. That's why there's no designation here about SUSE KVM. Ubuntu. Ubuntu is free. You can go out to the Ubuntu site and just download it. Done. Or you can order through IBM eConfig, and it's $758. Your choice. Confusing to me? Yes. That's what they did. Now, what's going on with these distributions? This is you can download this chart. I'm not going to obviously read it. It'll take too long. Only got 3 minutes, 5 minutes left. There's the /11, 12, and 15 roadmap, and when they are going into support. Same thing with Red Hat, RHEL 6. Notice there are two RHEL 7s. The one called Classic is the Big Indian only. And if you do nothing else and just order Red Hat 7 without designating alternate architecture, you'll get Big Indian. If you want Little Indian RHEL, you have to specify in the download Little Indian under alternate architecture. I talked with several customers that were trying to run a Little Indian application. They downloaded and installed unknowingly RHEL 7, Big Indian, and the application wouldn't run. So when they downloaded the correct one, it worked fine. So there's the RHEL alternate on the third line, and then RHEL 8 is coming out. RHEL 8 does not support the AC 922 at this time. 8.1, it will support the AC 922. That's why that's kind of important. That's next, well, it's not this year, Ubuntu. Power VM, fully supported. Red Hat Rev, supported. Bare Metal, supported. You can run Linux on the Nutanix boxes, but the Acropolis virtualization, which is KVM, is not supported. And believe it or not, some people say, can I run VMware? Can I on Power? No. On P-Hype or Hyper-V? No, you can't. So there's a table. I'm going the wrong way. Now, last chart. Good news. Last chart. There used to be a lot of red books on Linux on Power. And this is a list of them. None of these are up to date. However, they're not invalid, but you have to pick and choose wisely. Sometimes they're philosophical, like mission critical apps. Sometimes the Linux tuning may still apply based upon the sysctl settings of the build tree. And they give you guidelines as to how to change them for more performance. I don't do red books. That's it. I'm done. I hope you got something out of that. And I'll go back to my original statement that my discussion with Jeff Shield is, I think the Linuxes are different between x86, between SUSE, between Red Hat, Power. He goes, no, they're all the same. You choose. But hopefully this can explain to you why the Linux on Power is exploiting the hardware, and it goes back to the statement, look at the application and choose the hardware that's best for it. Linux does not make that an even playing field, where the performance, the reliability of Linux makes the hardware transparent. That is not true. I'm done. I don't know if there's any questions, so I'll go back to Joe.
Thanks, Ron. Actually, it's super interesting just to hear your little tidbits and the history and stuff. And I agree that, you know, Linux is Linux from a certain point of view, maybe a user interface, you know, a UI point of view and some other things. But when you dig down into the dirty little details of how it's interacting with the hardware, it's not the same because the hardware isn't the same. So it just depends on your point of view, which a lot of things, other things that you talked about really depends on your point of view. I think Tom's been really doing a pretty good job. Actually, it's been really interesting looking through the questions and seeing a lot of people have not only posted questions, but answers to the questions, including Tom. So it's been really nice to see the community out there doing that kind of stuff. There was several on, you know, can I just take the x86 Linux and put it on Power? And of course, no, you have to compile it for Power, right? And the same with applications, which you talked about. It has to be compiled for Power. You know, some great stuff there. I think
they can always post questions. You guys are very good at answering with Tom and you. And they've got my email on the front if they want to send them to me. And I'd obviously share them with you, Joe, so they can go out to the community.
Yeah, absolutely. If somebody out there, if you have a question or want some information that wasn't covered here, certainly you can send an email either to myself, my emails and all the stuff you get about the webinars from me, or else if you grab the deck, you can get Ron's email off of that and send the questions and whatnot directly to him as well. So feel free to do that. Otherwise, I think we've really had this pretty much covered, Ron, and I just want to say thanks again for doing this. It's just a pleasure. I love your presentation abilities, and I've seen you talk at TechU. I'm sorry, everybody, we missed out. Ron usually like throws out candies, M&Ms, bags of M&Ms or something during his talk, and so we missed that here.
But it's Halloween. If you stop by, I've got some.
Yeah, right. There'll be plenty of candy around tonight. So, so we missed that. But otherwise, you know, I love your speaking style, and it's very informal and full of information. So I really appreciate it, Ron. Thanks for doing this for the community, the VUG community here. So I'm working on next month still topic and stuff. So everybody, I'll be sending out invites for that. But otherwise, I want to wish you all a super happy Halloween, safe trick-or-treating tonight or whatever, and have a good month, and I'll see everybody virtually next month. And also, thanks to Tom Prokop for being in there and answering a lot of questions and stuff. Appreciate that, Tom, and everybody else that helped out.